Observe the Orion valve's PAMA in action, commanding attention as it prepares to machine enormous valve components. The vast work table stretches like a stage where raw metal begins its transformation. Each movement of the milling cutters reflects a blend of power and subtle control. Surface finishing marks the first step, setting the foundation for all subsequent operations. The production starts with high-quality metal blocks, carefully selected and inspected for internal flaws and structural integrity. Operators mount the blocks securely on the machine bed, ensuring absolute stability before cutting. The milling process removes excess material, shaping the surface to precise dimensions. Every pass of the cutter refines geometry, while coolant maintains material integrity and prevents overheating. Tool wear is continuously monitored, and cutters are replaced promptly to maintain accuracy. Operators monitor feeds, speeds, and cutting depth, making adjustments in real time to ensure consistent performance. Intermediate measurements are taken to confirm surface flatness and accuracy. Surface roughness is checked at intervals to guarantee smoothness for the next stage. Each rotation, cut, and adjustment during production reflects countless hours of calibration and engineering dedication. Orion Valve's PAMA's performance showcases how large-scale machinery can efficiently produce highly reliable components critical to global operations. Once the surface is properly milled, the machine initiates the boring process. The Orion Valve's PAMA drills precise holes, creating cavities essential for assembly. Operators observe chip formation to ensure the drill is cutting efficiently and safely. The drill's rhythmic action highlights the coordination between operator guidance and machine automation. Precision is maintained throughout, ensuring each hole aligns perfectly with the design specifications. Sensors continuously monitor depth and diameter, automatically adjusting as needed. Coolant flow is adjusted during drilling to avoid thermal expansion and maintain dimensional accuracy. After all machining is complete, components undergo strict quality inspections, including dimensional verification and surface finish assessment. Inspection tools catch any deviations or imperfections that require correction. Critical dimensions are measured multiple times to confirm compliance with specifications. Every component that passes represents the seamless interaction of material, machine, and operator expertise. The workflow demonstrates how careful planning and execution result in reliable, high-quality parts. Finally, the machined components are prepared for integration into larger systems, illustrating the culmination of skill, technology, and patience. The assembly-ready parts exemplify the harmony of human oversight and industrial power. The finished valves demonstrate durability, accuracy, and consistency required in demanding industrial applications. The industrial heartbeat of Carpinteria Mechanica resonates through each workshop, revealing human effort in every welded joint and machine surface. At the Moneli plant, spanning 500 square meters, the welded metal workshop begins the process. Sheets and blocks of steel are cut, aligned, and joined, forming the foundational frameworks of components. Sparks erupt from welding torches, marking the transformation of raw material into sturdy structures. Operators move with focus, ensuring joints meet exact alignment specifications. Once welded, parts advance to the milling shop, where rotating cutters shape surfaces and refine edges. Operators observe the chips as they fall, adjusting angles to perfect the surface. Each section of metal receives individual attention to ensure uniformity and smooth transitions. Subtle variations in metal hardness are carefully accounted for by the team, demonstrating their expertise. The milling machines operate continuously, creating a synchronized flow that propels production forward. In this stage, small adjustments make significant differences in the final component's fit and function. Every pass of the milling tool gradually uncovers the intended geometry, showing the skill behind each adjustment. The milling team adjusts feeds and speeds according to metal thickness, maintaining consistency across components. After milling, pieces undergo inspection and preliminary assembly to confirm alignment and surface quality. A growing anticipation fills the workshop as frameworks approach their final forms, reflecting careful planning and teamwork. Welded assemblies arrive and are refined in the respective workshop before reaching the painting shop, where protective coatings are applied. Each layer adds durability while subtly enhancing visual appeal, preparing components for operational deployment. Technicians monitor machines and communicate adjustments to maintain smooth transitions between cutting, milling, and finishing. Final inspections confirm dimensional accuracy and structural integrity. Each completed component is a testament to ingenuity, embodying strength, utility, and the persistent human touch behind every stage. A glowing 30-ton steel ingot, heated to 1,250 degrees Celsius, is lifted from the furnace and transported by crane toward the massive forging press. The immense weight and heat suggest the power and skill required to shape it. The manipulator grips the ingot and positions it into the 81/100ths of a meganewton open die press, reinforced with tie rods for high rigidity and accurate guidance. The first forging stretches the hood section to form a gripping neck. Each movement highlights the harmony between machine strength and human control. Meanwhile, the ingot is reheated, and the press is fitted with an upsetting plate specifically designed for the gripping neck. Once aligned, the ingot undergoes upsetting, producing uniform density throughout. Stretch forging continues under program control, creating a homogeneous microstructure through the core. The workpiece is forged first into a square and then an octagon. Watching the process, one appreciates how automation and craftsmanship combine to guarantee quality. Finished forgings are transported away for rapid retooling, supported by a die slide, table shifting device, and upper clamping and turning mechanisms. Polygonal ingots weighing up to 70 tons repeat the sequence of gripping neck stretch, upsetting, and final stretch forging. The press can handle tool steel, stainless steel, and alloyed structural steel, producing intermediates, profiles, bushings, rings, and discs for demanding industrial applications. It's impressive how high forces and program-controlled precision shape steel into reliable components. All manipulator movements, rotations, and lifting are harmonized for forward accuracy, while penetration depth is continuously monitored. The forge-based system allows optimization of schedules and energy use. Operators monitor and adjust the system, ensuring efficiency and reproducibility across every forging cycle. This combination of advanced hydraulics, mechanical strength, and program control guarantees forged products with excellent microstructure and consistency. The result is steel components ready for applications in power stations, shipbuilding, heavy machinery, and aerospace industries. The energy of metal shaping fills the workshop as bars are prepared for precise machining. 4 transfer machines move workpieces to CNC units, while single and multi-spindle centers refine each component to specification. The combination of machinery and human oversight ensures smooth and reliable operations. 6 more transfer machines maintain coordinated flow. 2 DMG Mori CNC centers handle larger parts, keeping dimensional accuracy high throughout the programmed sequences. Experience the intensity of industrial craft as FWG IHW's machines prepare to shape technical springs in Grevenbroich. Each coil begins as a simple wire, yet every movement hints at the strength and precision to come. The process begins with raw wire, carefully selected for quality and tensile properties. Samples of wire are pulled and tested to confirm elasticity before production. Wire is fed into coiling machines that bend and twist it into precise spring shapes. The operator monitors tension and rotation speed, ensuring each coil meets exact specifications. During coiling, small deviations are corrected immediately to maintain uniform pitch and diameter. It's fascinating to see a long, rigid wire gradually transform into a compact, resilient spring. After coiling, the springs pass through heat treatment ovens, strengthening the metal and giving it the desired elasticity. Glowing metal in the furnace reflects the energy transferred to each spring. Temperature and duration are carefully controlled to achieve consistent mechanical properties. Once hardened, the springs undergo grinding and surface finishing. Flat ends and smooth surfaces are achieved, improving performance and durability. Technicians measure and adjust end grinding to ensure springs sit evenly in assemblies. Small adjustments by skilled technicians make a critical difference in how each spring will function under stress. Springs are then inspected for dimensional accuracy and load capacity using specialized testing equipment. Load tests simulate real-world stress, confirming each spring can handle its intended use. Every measurement confirms the dedication behind these compact components. Observing the process gives an appreciation of the human skill combined with mechanical precision that drives such efficiency. Each spring is the result of careful material selection, exact coiling, heat treatment, and rigorous testing. FWG IHW's production demonstrates the thorough orchestration required to produce high-quality technical springs. Metal sheets lie flat under bright factory lights, ready to begin their transformation into robust Resipac drums. The first metal sheets are carefully inspected for smoothness and quality. Even a small imperfection could affect the drum's performance. Each sheet is measured for thickness to ensure uniformity across all drums. Defective areas are marked and removed before proceeding. The 2 edges of each sheet are brought together, and workers manually roll the sheet into a cylindrical shape, shaping it entirely by hand. Temporary clamps are used to hold the cylinder in shape before final pressing. Alignment jigs are employed to maintain concentricity during rolling. It's remarkable how hands-on skill still plays a major role in modern manufacturing. Once rolled, the cylinder is pressed with a stamping machine to finalize the drum's body. The pressing process forms a precise diameter and smooth surface. Ribs are then formed along the body to increase stiffness and maintain the drum's shape. The spacing and depth of ribs are controlled to provide optimal strength. At this stage, the drum begins to take the recognizable form of the finished product. Cylinders are rotated to ensure uniform rib formation around the entire body. Sensors monitor pressure during stamping to ensure consistent wall thickness. Cooling fans are used to stabilize the metal after pressing. Next comes the preparation of the drum ends. The top and bottom edges are rolled and pressed to create secure rims, ready for lid assembly. End caps are fitted and checked for proper alignment. The rims are sometimes spot welded or crimped to secure the caps. Torque-controlled presses are used to ensure consistent rim compression. Finally, every drum is checked for dimensions, shape, and strength, ensuring it is ready for safe filling and use. Any imperfections are corrected or rejected to maintain high standards. A sample of drums is occasionally tested under pressure to verify durability. The final drums demonstrate the combination of material quality, human skill, and machine support in production. Finished drums are then prepared for shipment or immediate filling. Inside the Andritz factory, submersible motors and hydrodynamic screw turbines are engineered for high performance and reliability. The scale and complexity of the equipment are evident during model testing, where engineers evaluate hydraulic efficiency under real operating conditions. The process begins with model tests and research at R&D centers in Austria, Canada, China, Germany, Finland, and Switzerland. This ensures knowledge and experience are shared across locations, maintaining consistently high standards. Metal components then undergo heat treatment to enhance hardness and wear resistance. This crucial step transforms the raw materials into parts capable of withstanding extreme operational pressures. Following heat treatment, precision CNC machining is applied to the impellers and other critical parts, refining their dimensions and ensuring strict adherence to technical specifications. This guarantees optimal hydraulic performance and mechanical reliability. The pump frame is then assembled with standardized components, forming a fully integrated unit. During assembly, skilled technicians continuously evaluate alignment and fit to maximize efficiency. Engineers and operators continuously monitor assembly, adjusting parameters to ensure stable and efficient operation in industrial and underwater environments. Finally, each unit undergoes rigorous final testing to verify performance before delivery. The pumps are prepared for applications such as water supply, irrigation, flood control, mining, pulp and paper processing, and energy production. The combination of advanced technology, systematic process control, and decades of experience results in products that deliver long-term reliability and efficiency. The production of metal sheets from S235JR steel is a vital process that impacts a range of industries. The journey begins with selecting high-quality S235JR steel plates, precisely 5 mm thick. The careful selection of material is crucial to ensure the durability and strength of the finished products. These plates are then loaded onto the Vimercati PHSY 150 by 3050 press brake, a machine built for consistent and accurate bending. As the material is carefully positioned, operators make sure that it is secured correctly, ensuring a smooth transition into the bending stage. The press brake's bending arm exerts powerful force to shape the steel, creating the desired angles with remarkable efficiency. Every bend is the result of an intense process of calculation and skill. The force applied by the press brake is carefully calibrated to avoid any deformation, ensuring that the bend is smooth and precise. Operators monitor each step closely to confirm that the sheet follows the exact specifications, preventing any discrepancies. In addition, the angle and curvature of each bend are continuously measured during the process to maintain consistency across all parts. After the steel is bent, it is checked to ensure its accuracy, ensuring that it perfectly aligns with the design needs. Once the steel plates have been bent into the required shapes, they're ready for use in various industries, including construction, manufacturing, and machinery production. Each bent sheet carries the potential to become an integral part of something much bigger. These shaped steel sheets play a critical role in building durable structures and machinery that power modern infrastructure. The Vimer CATI press brake is designed to guarantee that each part is manufactured to withstand the demands of heavy-duty usage. From the raw steel to the finished component, every step is handled with care to ensure no error. Once complete, the part is ready to be integrated into larger structures or machines. The combination of these advanced techniques and high-quality materials guarantees longevity and performance. The press brake's precision allows for versatility, making it adaptable to a wide variety of projects. As we reach the end of the process, the steel, once flat, has evolved into a key part in a much bigger system. Each finished component has been carefully checked, shaped, and tested to ensure it will serve its intended purpose in the toughest conditions. This process is a testament to the collaboration of cutting-edge machinery, skilled operators, and rigorous quality control.